Good morning or afternoon, depending on where you're calling in from. Thanks for joining us today for the SEAOC wind design discussion. We're going to get started here in a few minutes, but a couple of housekeeping things. There's a chat window at the bottom. If you would like to chat amongst yourself and your other fellow attendees, you can go ahead and use that. With that being said, we'll wait for just a few more minutes, let some other folks start trickling in. All right. Good morning, everyone. My name is Bernard Cruz with SEAOC. I'll go ahead and get us going here as people start trickling in. So welcome again to the wind design discussion here with SEAOC. Today's presenters put together a really detailed presentation. So if you do have questions during the slides and presentation portion, please use the Q&A bubble at the bottom of your screen. You can click on that. We can keep track of the messages, and we will take care of that as we go. Uh, if you have any difficulty during this session, please email our administrator at seaoc@seaoc.org for any assistance during the presentation. So without further ado, I'll go ahead and introduce our speakers. Our speakers today is a pretty esteemed panel of experts in the wind design space. So first, we have Gwenyth Searer, principal at Wis Janie Elster and Associates. She is a licensed structural engineer in 6 Western states, including California. She has over 30 years of experience and is the chair of the SEAOC Wind Committee. Dr. David Banks has been with CPP Wind Engineering since 2000 and has been president since 2020. He is a member of ASCE 7 Wind Loading Subcommittee, the ASCE 49 Wind Tunnel Testing Committee, and the ASCE Solar Manual of Practice Committee. Stephen Kerr is a principal at Joseph and Werda Watts and Associates, Incorporated. For nearly 20 years, he has participated in SEAOC and NCSA committees, including serving as a past chair of the SEAOC Wind Committee and helping to develop SEAOC's Structural Seismic Design Manual and SEAOC's Wind Design Manual. He's a licensed professional and structural engineer in 5 states, including California. Meaghan Halligan is a senior associate at Degenkolb. She is a licensed structural engineer in 3 Western states, including California. She has over 20 years of structural engineering experience, primarily in the design of non-structural components. She is the vice chair of SEAOC Wind Committee and is an ASCE 728 voting member on both the non-structural component task committee and the seismic subcommittee. Emily Guglielmo is a licensed structural engineer with more than 2 decades of structural engineering experience and is currently a principal with Martin & Martin. She's past president of SEAOC, chair of the NCSEA Code Advisory Committee, and a voting member of the NCSEA, SEAOC, and ASCE 728 WIN committees. So without further ado, I'd like to hand it over to Gwen to get us started.
Thanks, Bernard.
Take us away.
Again, if anyone has any questions, please enter those questions in the Q&A down at the bottom. Okay, and we're gonna have some presentations in the beginning, and then we're gonna have questions and answers, and then we're gonna break into discussion and have a little bit more interactive, try to figure out what we want to do with the wind design in Southern California. Our learning goals are to understand the status of wind design in Southern California, recognize how we got here, be able to discuss what basic wind speeds are, and what special wind regions are, learn how basic wind speeds are developed from wind data, and chart a path forward for the future, for the coming code changes, because there are some substantial ones coming. So again, we're gonna have presentations, then questions and answers, and then discussion. Okay, so first thing is we want to figure out who's here, what your group experience is. So we have a few polls, and I'm going to launch the first one here. First one is who is attending. So if you can all answer, you should see this on your screen. We'll leave it up for just a few minutes, less than a few minutes. Just let us know who you are. Okay, looks like most everyone has answered. Should have popped up on your screen. 41 of 46 have answered. So I'm going to end the poll and share the results. So we have roughly 12% building officials, 10% plan checkers, 68% practicing engineers, and 10% other. Let's do our second poll. And here we go. So what are your concerns with respect to wind? Are you worried about the overall structure? Are you worried about components and cladding? Are you worried about both? No one wants other. One more second. Oh, someone chose other. Thank you. All right, and go end the poll. Last chance. And share the results. So interesting, we have a few people are just worried about the structure, a few people just worried about components and cladding, and pretty much everyone else is both. Third poll. And this is there history of wind damage where either in your jurisdiction or where you practice? Give it another 10 seconds. Okay. And maybe I gotta publish the results here. Maybe during the discussion, we can talk about what kind of damage you've seen. This looks like a few instances of wind-related damage is the primary choice, but no damage is a close second. And one person says there's been a lot of wind-related damage. Yeah. Maybe, okay, sorry. If I go back, next one is special wind regions in your jurisdiction or where you practice. And this one's a little wordier. Give it 5 more seconds. All right, show the results. Few of us are just working exclusively in the special wind region. The majority are, have some involvement with the special wind region. A decent chunk have no involvement with special wind regions. And we have a few honest people who are wondering what is a special wind region. A few more polls. This is for building officials and government administrators only. And I realize we only have a few of you. So does your jurisdiction mandate wind design parameters that must be used? Five more seconds. Okay. Roughly 2/3 say yes. Jurisdictions do mandate the wind design parameters that must be used. 2 more polls. Again, this one is for building officials and government administrators only. If you do have, now this is a smaller percentage, if you do mandate wind design parameters, how are they selected? Be honest. We're not saving any of these results other than kind of group, not individual. Five more seconds. Right. No one chose dartboard. Looks like almost 2/3 were selected by a predecessor. So they're being carried forward from the past. A few of you have retained an outside consultant, and a few were just selected by the building official or administrator. Very interesting. And last one, again, for building officials and government administrators only. Let me see if I can make that bigger. Okay. Do you feel you have the tools necessary to select those wind speeds or wind criteria? Give it 10 more seconds. All right, last chance. And the results. It's kind of a shotgun. Some people aren't in special wind regions, so it's easy. Some of you are in special wind regions and you've figured out the correct wind speeds. Some of you just let the engineer decide, and some of you don't know what it should be. All fair answers. I'm going to close the polls. So I'm going to hand over to Stephen Kerr. Steve's going to talk about a survey that was done by DSA. So I'm gonna stop sharing. And Steve, if you want to start presenting, hit to unmute.
All right, thanks, Gwen. So let's go ahead and pull up my part here. All right, can you see that?
Yes, you're good.
Okay, good. So thank you, Gwen. As she said, my name's Stephen Kerr. I'm former chair of the Wing Committee. And so what I'm here to talk about is a survey of authorities having jurisdiction here in Southern California with the special wind regions. Several years ago, DSA, Division of State Architects, reached out to us to kind of share some of their information they had. And so this is their survey, not ours, but I kind of want to bring it forward so we can make you aware of what the state of practice is for the region. And so for us to know, DSA does not develop loading requirements for projects that they plan review. Rather, they use the loading requirements from the local jurisdiction. So they defer to the building officials to set what the requirements are for the buildings they review, and they don't do that themselves. And what they were finding during their plan review process, that there was not necessarily a uniformity in how engineers were addressing wind within their designs. So you guys may be seeing this too, but there was a big range of the way people were handling wind. So what they did to understand better what jurisdictions were doing in 2017, and then a follow-up in 2020, the DSA office here in San Diego, which is responsible for San Diego and Orange County, the southern part of the state, they conducted a survey of the authorities having jurisdiction. And so in that survey, they reached out to all the cities and counties in San Bernardino, 25 cities in the county, and then Riverside, 26 cities in the county, and then Orange County, they reached out to 3 cities near the special wind regions. So we're really focusing on San Bernardino and Riverside counties in their survey. And what they did look at was compiling the data for risk category 2 and 3 buildings, as well as the local jurisdiction's wind speed requirements and exposure requirements. And to kind of paint the whole picture, they also took into account what the ASCE hazard tool and ATC hazard tools had for the cities, and Gwen will be talking about that later on, but we'll just kind of give you some highlights from this study, and this was for the 2019 CBC. So it's not current, but it gives you kind of an idea of what the state of the practice is throughout the region. So in the jurisdictions, 39% had an exposure requirement. So an exposure C wind requirement versus an exposure B. So some jurisdictions are mandating or giving a requirement for the exposure for their cities. This was interesting that 15% had identical wind speeds for risk category 2 and 3 buildings. So with the 2016 ASCE, the wind speeds were different for different risk categories because the importance factor was removed, but some jurisdictions had not adopted those requirements. And this isn't anything from any of the jurisdictions, but even the hazard tools, the ASC versus the ATC hazard tools, they had different results when you would type in a city address or a city name. So, you know, the job of creating requirements isn't easy. And then one thing we did, or that I did, was I took that results and kind of summarized it this way, that we found that 13% of the authorities having jurisdiction were fully within a special wind region, but 37% are partially in or partially outside the special wind region. So there's quite a few jurisdictions that are both in and out, depending on what part of the city you're in. So, you know, we've got these results that we incorporated from them, but to summarize, we wanted to show it visually. So here you can see, kind of looking at the region, kind of blowing up, where you could see the different cities and wind speeds from 2019. And what I did was I took the 2022 ASCE special wind region and kind of overlaid it to show where we can see there are some regions where they have lower wind speeds that are in special wind regions, but then some of the regions have higher wind speeds that are not in special wind regions. And so we're looking to kind of bring this forward with a new study, hopefully completed next year, where we can resurvey all the cities and kind of revisit this topic. So one of the things we'd like to highlight, or I'd like to highlight, is that we have these hazard tools. Those are definitely an easy way for people to see what the wind speeds are. And if you do want to mandate exposure categories, a default is okay, but it's great to let engineers do the engineering and evaluate the exposure category. So that is kind of the little part I have, Gwen, in a nutshell here. I'll go ahead and stop sharing and turn it back over to you.
Thank you. I'm going to start sharing again. Okay. All right, so how did we get here? We figured it would be a good idea to talk about how we got here and present a brief history of wind design, particularly in California. Okay. First wind design in California was the 1927 UBC, at least for kind of the whole state. And it was pretty simple. If the portions of your building that were 40 feet or less get 10 PSF, and the portions that are higher than 40 get 20. And these are all allowable stress design levels. And this is the entirety of the wind design provisions. Those of you who do a lot of design these days know that it's chapters of the code now. This was just 4 paragraphs. Very simple. Probably not a lot of people made errors in figuring out what should be done with their building in terms of what the loads are. 1932, they tweaked the height limits a little bit and bumped up from 10 to 15 pounds per square foot, the minimum load. But they also said, well, you get a 33% increase in allowable stresses for combined stresses. So it probably negated most of that change. In 1961, that's the first instance of a map where you can look at a map and go, oh, I see where we are. So in California, it's mostly not shaded at all, which is 20 pounds per square foot. There's a little area on the Northern California coast, and that area is 25 PSF. And then you would take these values, either 20 or 25, depending on where you are in California, go to a table, and you'd look at the 20 pounds per square foot, and depending on how high your structure is and what areas on your structure you're looking at, these are the wind pressures you'd use. Along the coast, you'd use somewhat higher loads. You can see here, there's not a lot of significant figures, right? Everything's multiples of 5 PSF. Pretty simple. There is, for the first time, some sort of mention of Santa Ana winds, which affect Southern California. These pressures, there is a little caveat that says the wind pressures from that table shall be adjusted by the building official. Doesn't tell the building officials how to do it or what number to pick, but it leaves it up to the building official to decide. In 1982, the provisions had ballooned to 5 pages, which, you know, are much closer to current design provisions than what I just showed you. These wind speeds are based on what's called fastest mile wind speed. So fastest mile is the time, if you take the time it takes for a mile of air, 5,280 feet of air, to pass by you, then you can compute the wind speed. So for example, if it takes a minute for a mile of wind to pass by you, that wind is moving at 60 miles per hour on average. And these wind speeds are based on a 50-year mean recurrence interval. And it's a 2% chance every year on average that these wind speeds will happen. So you're going to see them fairly often if you've lived in an area for a while. It's certainly quite possible you could get 2 or 3 in a certain period of time, you know, years. Anyway, you know, for California, most of the state was 70 miles per hour. That's the entire shaded region. The northern coast was 80, and then somewhere in between. This grainy map was really all we had. And I remember on one project looking at San Francisco and trying to blow up the map and copying it again and again and trying to get better resolution, but you know, you can't. That's all we had. There is mention of special wind region. There's a like shaded areas that show special wind region, but they're actually not mentioned in the code at all, other than just the shading. It does say where you have terrain or local records indicate the winds should be more, you should use a higher wind speed, but it doesn't provide any guidance. In the 91 UBC, special wind regions were actually mentioned in a provision for those areas designated as special wind regions. Use higher values if appropriate, basically. And they defined it for the first time. It's an area where local records or terrain features indicate 50-year fastest mile basic wind speed is higher than that shown in the figure. Not a lot of guidance, but at least we're getting there, right? We're starting to define things. So then California was on the UBC for a very long time, and then we switched to the 2006 IBC as our model code, and ASE 705, 2005 is the basis for the loads in the 2006 IBC. One of the changes is switching from a fastest mile wind speed to a 3-second gust. Now, it's not that gusts weren't considered back then, but the profession decided that switching and just approaching 3-second gust as the design basis was more appropriate. In addition, if you look at these two maps, on the left is 97 UBC and on the right is 2006 IBC. You can see the special wind regions, and there's big changes, right? The arrow on the left is showing a very narrow band of special wind region, and the arrow on the right is showing a very wide band of special wind region. And down near LA, that special wind region is now bigger on the right and has moved to the west, which that's where LA is, Los Angeles. Suddenly, we had several million people and hundreds of thousands of buildings were being shown as being in a special wind region. And that's a problem, right? And we weren't considering that before. So the LA County Department of Building and Safety didn't know what to do. They're responsible for it per the code. And so they decided to increase the 3-second wind gust from 85 to 100, which, doesn't sound that much, 15 miles per hour. Now, forces and pressures are based on velocity squared. So, it's probably actually it's 38% increase in load. And it was based in part on a newspaper article that had reported 100-mile-per-hour wind gusts. And that was in the mountains, so it's probably not super informative. And it was based on a concern about Santa Ana winds. So what do we know? Well, we know in the LA basin, there's no history of significant wind damage or even strong winds. So SEAOC, Southern California, put together an ad hoc committee, study the issue, and make recommendations. The committee realized pretty quickly that the special wind regions had been morphing over time, basically due to whether it's drafting errors or drafting decisions, but going from one version of ASE 7 to the next. Those special wind regions were developed by a single person in just before 1982, a guy named Hugh Church. He was a meteorologist, and he basically drew on a map where he thought there might be unusually high wind speeds. Those got incorporated into ANSI A58.1, and they got subsumed into ASE 7. They had never been revisited. They were still the same regions that he had drawn on a map a long time ago. But they were changing from code to code despite no changes in data or knowledge. And so the special wind region that was originally in northern Los Angeles County moved south and west during that drafting. So if we look at a progression of maps here from 1993 on the left to 2010 on the right, you can see a big change happened from 93 to 95. And the way the special wind regions were drawn changed from sort of a hatch to what looked like hand-drawn lines. And down in Los Angeles, that's where the big change happened. But remember, California wasn't adopting ASE 7. It wasn't adopting the IBC. IBC didn't exist then. UBC did not adopt ASE 7. So no one was paying attention to this in LA or anywhere in California, really, because we weren't using this standard. So it just kind of moved along until suddenly it got adopted. And then everyone realized we had a problem. So the ad hoc committee studied wind records from Burbank, LAX, and Ontario, and other instruments that we could find. It turns out the LA basin's pretty well insulated from Santa Ana winds. It's in a basin, right? So this is on the right, you'll see a very colorful plot. It is showing the results of what's called mesoscale modeling of an actual, like a storm, a windstorm. And you can see in downtown LA and the surrounding areas, the blue is really not much happening. The red, the yellows and the reds and the oranges are all high wind speeds, and the blues are not. Now, this is just one storm, but it's a pattern that was observed. And in published articles, same thing. Here I've outlined in red LA County, and you can see the LA basin, not much is happening. The Santa Ana winds largely are routed around LA Basin. So the ad hoc committee recommended going back to 85 miles per hour, so no special wind region. You could actually use the records we have to justify a lower wind speed, which would be even lower than ASC requires outside of the special wind region. But we didn't recommend doing that, but we certainly recommended eliminating the special wind region in LA County, at least in the areas that were affected by this shift. And LA County agreed and rescinded their policy, which was fantastic. Good result. And the ad hoc committee recommended that other areas of LA County be investigated because there are some areas that kind of light up during storms and do see significant winds. Okay, so I'm now going to turn it over to David Banks, and David's going to talk about how engineers and meteorologists and wind engineers use wind data to develop special wind, or not special wind regions, to define them and determine what appropriate wind speeds are. Stopping sharing. David, if you want to, yep, you're good.
Yep.
Go for it.
All right, so I'm going to share. All right, so hopefully everybody can see this.
You're good.
And as Gwen showed, there's ASC 7 has these special wind regions. They've moved around a little bit over the years, as described, but not a lot has been done to define what the speeds are or explain why they're there. So we're going to talk a bit about that over the next 10 minutes. Look into that. In particular, so on the left of these first few slides is the language right out of the code, right out of ASC 7. And the bit highlighted in yellow is what I'm going to begin talking about, which is how to figure out what the speeds are when you've got a special wind region. And in the map on the right, you see some special wind regions shown in red. Those are SWRs that have been examined closely. And the two with the red arrows, there are actually speeds now in the ASD hazard tool, which Gwen will be discussing after I'm done. So how do we get from here to there? How do we get those speeds? Well, so ASC 7 says, well, what you can do is follow the same procedures we use to get the map for the whole country, only you're going to do it sort of locally. And I guess before jumping into that, we should probably talk a little bit about why you'd want to do it locally. Most of these special wind regions are drawn over top of mountain ranges. Some are not, like the coast of Oregon and Washington, but certainly where our office is in Colorado, we're in one. And when we look at it closely, we see that the boundaries change. Now, why would we have a special wind region here? It's because of downslope winds. So downslope winds are perhaps most notorious for causing and spreading fires. This is on the upper right, we have a simulation of a downslope event in Hawaii that caused the recent devastating fires. And on the bottom and on the left, we have a video of smoke spread during the Marshall Fire in Colorado, again, during a downslope event. One of the things that makes these very hard to predict the wind speeds is there's this thing called the hydraulic jump. So the wind is racing down the mountainside, and then at some point suddenly jumps up, and it's hard to predict the point at which it's going to jump up. So it's hard to predict how far across the plains these high winds are going to extend. So that's what you get then are really rapid changes in wind speed and design wind speed as you approach the edge of the mountains. One county that commissioned a study to take a look at their special wind region was Kerr, and this is the map that resulted from that. You can see on here, there's some lines indicated 1 and 2. Those are sort of approximate contours of what the sort of background ASC 7 wind map would say. And so that's a 2 mile per hour difference in the design wind speed between line 2 and line 1. Whereas between line A and line D, we have closer to a 30-mile-per-hour difference in wind speed as we get in tight to where the downslope winds are the strongest. As I mentioned, the process. So here's some text again from AC7 describing what you can do. They say, well, go get some regional climatic data to figure out what to design wind speeds are in your special wind region. And that's what they did to come up with the map for the US. Every one of these dots represents an anemometer, almost always at an airport, which was where they used the data to come up with the map for the US, excluding the hurricane zones, which is a whole other topic. So you get data from all of these points. Now they exclude some stations. There are more stations than this. And one of the reasons they exclude stations is that if it's a bit of an outlier, it doesn't fit with what's going on regionally, sort of across Southern California. And you'll notice, I'm going to zoom in here on the LA Basin, that there are no dots between LAX and San Diego along the coast. And all of these stars represent airports that were ignored. So what we're going to do for the special wind region is we're not going to ignore them anymore. We're going to dig into it and decide, why are they so different from the surroundings, and do they justify a higher wind speed? And just for reference, here's the special wind region up until 2016. Well, perhaps as we saw, they change a fair bit, but this is the one we were starting with when we examined the area. Okay, then the code again on the left is giving us some details about how to do this. They have these two steps. We'll start with the second step, which is basically a series of details that you want to watch for. Do you have enough data? Is it reliable, or are there trends? And if so, how can you account for them? Essentially, data quality issues. And from one of our reports for Southern California, here's a figure illustrating an example of a data quality issue. You see at Lancaster Fox, suddenly there's a lot more high gusts in 2007, and that continues until 2014. So we don't believe that the climate suddenly changed for 7 years and then went back. So we go in and take a close look at these, and you find that they are erroneous, and there are various ways to figure that out. And it's part of a scrubbing of the data that has to happen, a close examination to make sure that the storms you're considering really happened. And there's a whole process to doing this. You look at radar, you look at records, incident reports, damage reports, all kinds of things to be sure that when you put a wind of 80 miles an hour in, that it really happened into your analysis. It's probably worth backing up a little bit and talking about where all this data is coming from. This is a picture of an ASOS anemometer. That's the automated surface observation system that is standard at most airports now. The switch to ASOS was fantastic. From a perspective of someone who's looking at wind speeds at airports, suddenly they're a lot more consistent. They had a whole bunch of rules about where you can put the anemometer, how far it has to be away from other structures, the sampling rate, all kinds of things. So ASOS anemometer, ASOS data is quite reliable. But if you do have an anemometer, and we'll talk about trying to get data in the mountains of the special wind regions, you're not likely to be able to meet all these criteria. So now you've got to correct for all kinds of things. Is it on a hill? Is it in the wake of some trees? Is it not at 10 meters? Various things that have to be done. Okay. The other requirement when doing one of these analyses that ASC7 places is that you use extreme value statistical analysis. So here's an example of that type of analysis. And this is the kind of thing that's done for maps, well, for the ASC7 maps themselves, but for maps around the world. This is sort of the accepted practice. On the x-axis from left to right, we have the return period, or you might think of it as the MRI, mean recurrence interval, of a wind speed. So as we wait longer and longer, we get a higher and higher speed. All these lines are moving from bottom left to upper right because of that. Every one of these little blue triangles represents an observed wind speed during a storm. And From a given storm, you take a single observation. So if the storm lasts all day, you get one wind speed out of that storm. It's meant to be the peak thing that's independent. So each one of these, you wouldn't have one storm creating multiple triangles. And then we fit a line to it. And you can, and so that's the red line. And then we're on here also for comparison are the lines fit to the code values. So the ASC 716 and ASC 710. And you see here that Barstow Daggett has higher winds than the code would predict, but only for periods of less than 10 years. Once you get past 10 years, these regular high winds that give it a reputation for being a windy, dusty place are not impacting the design winds, which happen, are sort of 50 years if you do an ASD, or 300, 700, 1 in 700 year event for a risk category 2 structure when you're doing strength design. Another key part of doing these approved extreme value statistical analysis is the storm separation. It's been long accepted that you would want to look at hurricanes separately because they're infrequent and severe. Over the past 20 years, it's become apparent that we also need to separate out the other kinds of storms. So those downslope winds I was talking about, they get their own extreme value plot, and so do thunderstorms. And so here's an example of a time history. Part of the procedure of coming up with that plot. This is how we come up with one of those blue triangles. So we're looking at data from the Palmdale Airport, and we see here, in the middle of July, in the middle of the afternoon, they had a thunderstorm. These little pluses up here indicate that there was thunder observed or lightning observed. And this very sudden rise in wind speed and dropping back down is characteristic of an isolated thunderstorm, and also a sudden change in wind direction. So we're going to pull out all the different kinds of storms and fit separate curves to them. And when you're all done with this, you come up with a design wind speed, 50 year, 300 year, 700 year MRI design speed. Every time we look at a special wind region, we find that we're going to change the borders, and in some cases eliminate it entirely. So here is an example from Modoc County in Northern California of the special wind region. We could find no basis for this. So our recommendation is that it should go away. And we think it might have been drawn in the wrong spot, because typically these are on top of mountain ranges, and there's a mountain range about the right size, a little bit to the east. But we don't have information about the basis for why this was placed here. So it's just speculation. Like I say, every time we look, we end up moving the borders. We look closely at these ones down here. Gwen's going to talk a bit more about the changes, how these came about. But perhaps the most important message here is, I've gone over the details, the science behind it, but there is no need for these special wind regions to be a mystery. It's just a question of how much work it is to get a good answer to be able to figure where the boundaries are and to figure out what the speeds should be. And I'll say it is great to see that we're getting these changes, areas studied and changes put into ASC 7, but there's still room to improvement, even in the regions where we've defined speeds, like Kern and in Colorado. And with that, I guess that's my session's over.
Thank you, David. And again, I'm going to talk just a little bit more, and then we're going to have some questions and answers, and then we will go into discussion. So you should be able to see my screen again. Make sure I'm not muted. Okay. So SEAOC Wind Committee. I had talked about what SEAOC Ad Hoc Wind Committee did. Now I'm going to talk about what SEAOC Wind Committee is doing. So just the California as a whole. So from the change from ASE 710 to ASE 716, basic wind speeds dropped substantially across the country, or certainly in the area of California, right? We went from basically 110, which, the way I've drawn it, it's not perfect. That 110 also applies to all of California. And to somewhere between 90 and 100 for the global like statewide trends, right? So we're somewhere in California, usually somewhere between 92 and 98. That's just where California falls in those contours. And you can see that the special wind regions were corrected. They basically reverted back to the areas that Hugh Church drew in the 1980s, early 1980s. So we got an improvement, right? We narrowed the special wind regions. They're back where they were originally intended. And the basic wind speed dropped over the state. We also eliminated the importance factor. So this was the old importance factor table from ASC 710, and it's no longer there in ASC 716. Instead, we have 4 different wind maps, one for each risk category. The importance factor, if we look back, this was just a crude approximation. You can see there's actually no change from risk category 3 to risk category 4. It was just a 15% bump, and it was a 13% reduction to go from risk category 2 to risk category 1. Risk category 1 is like agricultural buildings where people aren't at risk. So now we have basic wind speeds for each of the following return periods. So risk category 1 is 300 years. Again, that's for kind of unoccupied structures, very low risk to humans. 700 year is the average return period for risk category 2 structures. So you remember fastest mile, we were designing for a 50-year return period, and those were allowable stress. Now we're in strength design, and we're designing for up to 3,000-year return periods. So every 3,000 years, on average, you'll see a storm that's equivalent to what risk category 4 structures are designed for. And now ASCE has made their hazard tool free, and it's constantly being improved. I want to show you how it works if you haven't used it before. So I just chose Rialto as a sample. So you can type in, and either you type in a city address, like just Rialto, or if you know your property, you can type in the exact address and it will find it. You tell it which standard you want to look at. So in this case, ASC 716, risk category 2, you can set it to 1, 2, 3, 4. Wind we're looking at, and you just hit view results. The results pop up. It does the interpolation. It says, wow, you're at 96 miles per hour. And it has a nice feature called overlay. If you turn that on, you can see where Rialto is, and you can see the relationship of Rialto to the special wind region. Pretty cool. It eliminates doing what I did back in the day with copying something on a copier and then blowing it up multiple times to see where you actually are, and then trying to overlay a map with streets on it or whatever. This will get you. You can zoom up on this. However, if you zoom up any further, the special wind region goes away and you can't tell where it is. You'll still be told you're not in a special wind region. It won't flag it. But you can't zoom up more than that on the special wind regions. So after ASC 716 was published, SEAOC commissioned a study of that special wind region, and it was performed by Dr. Banks at CPP. And this is the original outline. And as David showed, there were recommendations. In some areas, the special wind region shrank. It was not applicable to some geographic areas. And in other areas, it got bigger, including now covering Ontario and the Ontario International Airport. So these changes you will see in the next code in ASC 722, and that will be adopted in California very soon. So going back to Rialto again, you can see that Rialto's not in the special wind region. But the special wind region has morphed, it's gotten bigger, but this time the morphing is deliberate, right? There is data that justifies higher wind speeds, for example, where Ontario is. So if we look at Ontario, oh, that's Rialto. So, and you can see here, if you ask it for its results, it will tell you all 4 different wind speeds, and it makes it easier to pick out what you should be designing for. In this case, 96 for a standard structure. All right, now looking at Ontario, I just typed in Ontario International Airport. I could have typed in Ontario, or I could have put in an address, doesn't matter. But since I sometimes fly in and out of Ontario International Airport, I just chose that. ASC 722. I chose risk category 2 just for the sake of it. Obviously, an airport is probably not risk category 2. Wind, view results, boom. Now, it gives you the contour, which is 95 miles per hour, but it also says, hey, you're in a special wind region, right? So it flags it, and it says see details. So if you click details, here's what details say. Again, it gives you the wind speeds, but it also gives you a warning, hey, you're in a special wind region. And it says, authority having jurisdiction shall, if necessary, adjust the values to account for local higher wind speeds. So we studied this one special wind region, and in doing so, we realized that there's another area that needs a special wind region. So we took 1 step forward and 1 step back, and that is this smaller area down at the bottom. This one. And this is down near Irvine. So the next code, California Building Code, will have a special wind region in this area. It's Santa Ana, Irvine, a little bit of Anaheim, all affected by this. All right. And so we also studied this one. We commissioned another study to study this new special wind region. And the results of that study indicated that the old wind speeds, ASE 710 wind speeds, are probably more correct for this special wind region than the statewide contours. So if you remember, we switched from 110 to somewhere between 90 and 100. So the results of the study indicated that that special wind region is probably more like 110. But we don't have a lot of data there. There's just a limited number of airports once you start getting to small areas. So what we recommended, and it's in a white paper, is that there's the hilly area, the kind of mountainous, the foothills, going up to the peaks of the mountains will have a 110-mile contour, and then we'll go up to 120. And the outer perimeter of the special wind region will be the regional contours, so roughly 95 to 96 miles per hour. And we felt that's a reasonable compromise here. So we don't have a jump from 95 miles per hour on one side of the block to 110 on the other side of the block. This is a more gradual way of dealing with it, and it's reasonable, right? Is it perfect? Probably not, but it's reasonable. So here's a little a blow up of it, and we have maps for all 4 risk categories. So the work becomes more, right? You can't just go use an importance factor of whatever. You actually have to develop maps for all 4 risk categories, and we've done that. We also commissioned another study, and that is this area highlighted in red here of the San Gabriel special wind region. And The results of this study are that this area right here actually isn't affected by Santa Ana winds significantly. So our recommendation is that this area, this notch in the special wind region, can be ignored, and that the special wind region should actually be notched around this region, because Santa Ana winds are flowing this way towards the south and west, and they don't concentrate. They're not downslope. They're kind of going up the mountain. So they don't accelerate like they do on the other side of this special wind region. So we believe there's enough data here to justify cutting out this notch. Kern County also commissioned their own study, lots of studies. So you can see here, this is a map for ASC 716. This shows the special wind region in the southern portion of that area. And you can see it curves south and east. In ASC 722, it goes the other way. And this is what David showed earlier. It has very tight contours. And for risk category 2 structure, you go from 95 miles per hour at A to 130 at D. So for example, Mojave Airport would be somewhere between B and C. So somewhere between 110 or 120 for risk category 2 structure, or 115 or 125 for risk category 3. So SEAOC's next steps here are to publicize the results. We have a white paper that describes these most recent studies. We're proposing changes for ASC 728, so hopefully that standard will have some of these changes. Ideally, we might demarcate the special wind regions, but the hazard tool would allow you to find the actual recommended wind speed in that area. That's probably our primary goal, is to get that for most of the special wind regions. These are expensive, so we are in the process of raising money to fund more studies to better define our special wind regions in California. So we have a white paper. Anyone who attended here today will be getting a copy along with a copy of our slides. But right now we're going to take questions. So questions on the formal presentations, and then we're going to go into a discussion. So I'm going to stop sharing. And it looks like we have a few questions and answers. The first one is just a comment. It says, those were the good old days. I assume that comment was when I showed the 4 paragraphs of wind provisions. Oh, wait, start my video. Oh, I'm sorry. I thought it was started. Okay. Northern region of our jurisdiction is special wind region. This is the question. So we applied special wind to the entire city so that we can eliminate the confusion and not take the chance that a building or site was missed that actually needed it. So it's not really a question. I mean, that's a possibility. You can do that, but the ASC hazard tool allows you to type in the actual address. And as I just showed you, it's very specific as to whether something is in or out of the special wind region. So it's no longer blowing up graphs or blowing up figures on the Xerox and doing it multiple times to zoom in. It's now digital, it's digitized, and that hazard tool allows you to tell exactly whether an address is in or out of the special wind region. So, I mean, you could make an argument that that's not so confusing anymore, and it's much harder. Like, all they have to do in their calc submittal is say, here's my address, and it'll show you if you're in a special wind region or not. Next question is there any way to get access to the recording? Yes. We we'll figure out a way. We've recorded this, and it will be made. It can be made available. Another question. Aside from special wind regions, why are separate maps required for buildings with different importance factors, rather than just using an importance factor multiplier on one map? Yeah, we have 4 maps, but there is only one physical reality. That's a fair question. I'm on the ASC 7 main committee, and I had similar questions. The truth of the matter is that those importance factors were crude. They were easy, right? You just take it times 1.15, but they're not particularly accurate. And they're not getting you what are, we're moving towards a more coherent or logical or whatever, more risk-focused and probability-focused code. And by just using a 1.15 factor, you're missing out on details. And if you look at the hazard tool, it actually gives you recurrence intervals from like 1 year to 100,000 years. So depending on the structure, you can design for more than the 3,000-year wind event if you wanted to. But at least if you say, oh, I have a risk category 3 structure, you will be designing for a 1,700-year return period wind. And with the 1.15, it varied all over the map. No pun intended. Okay,
Hey,
another
Gwen.
question. Yep,
Hey,
go
Gwen,
ahead.
can I jump in for a
Sure.
second?
Yeah, absolutely.
Let me go ahead and share my screen here.
Yep.
We've done part of what I've been working on, my section here of looking at these special wind regions and trying to take the wind data. You went through the hazard tool and described on how you can put in a city or an address, and you come up with the map showing you whether your wind speed, whether you're in a special wind region or not. And we've been kind of trying to take that data and look at it on a map. And so, for somewhere like Rialto, here's getting up near Rialto. You can see up in these regions, a lot of those cities cross over the special wind regions. And so
they're part in, part out, right?
Part in and part out. And so it becomes a lot easier when you've got this tool to use as a backup for looking at it, because you could see here, here's the ASCE 7 line, and it crosses through many of the jurisdictions. So you could see here, taking that line off and then putting it back on. So cities like Fontana or Rialto, you get portion of it outside the wind regions, which wouldn't need anything special, but then portions of it within. So it's a good way for us to, as engineers, justify being outside a special wind region. Now, when you're in these special wind regions, more work is needed, like you talked about with these studies. At least for the Irvine one that's down here, we are proposing those contours. But for the larger Southern California region, we don't have that data yet, but at least the in and out is pretty easy to know by your address within even the cities that are crossing those boundaries.
Right. Just to clarify, what you're showing right now, that's not the hazard tool.
No, that's correct. This is taking the information from the hazard tool and just importing it into Google Earth to be able to process it. If we just did that same thing and I type in Rialto here in the hazard tool, you know, and get the overlay, it's nice to see where the region is, but you know, when you start zooming in, you lose that contour line, which is a shortcoming of the hazard tool.
Right. Now, why don't you hit the back button, the upper, that kind of U-turn thing, and instead of typing in Rialto, which is just kind of whatever Google or whatever thinks city center is, right? Instead, why don't you click somewhere near that boundary? Because you can just do find on map and click. So maybe click a little bit north of the 210.
Yeah, so here we're kind of right there.
Yep.
And we're
If you go
not
to
in
the
it, but if we go back, I guess,
Yep.
try
Just
to
a little
click
bit. Yeah, go
just a
right
little
there.
bit further north. Now, yes, see, we are within the special wind region.
Right, which actually leads us to the next question here, which is the hazard tool does not provide the special wind region speed. How do I determine the wind speed? Well, that is the $64,000 question. I think I'm dating myself. I think $64,000 doesn't go as far as it used to. So we don't know. I mean, it technically says the building official is supposed to determine it, but the building official is also supposed to determine it based on what David presented, which is like an actual study. David, you want to jump in? You go for it.
Yeah, I mean, that's the study that I was describing is how you would get those numbers. So the how in terms of the science is described in the code, and it's sort of established in the industry, but the how in terms of getting the study commissioned, finding out if you've got enough data, as when mentioned, as you get into these small regions, there's not likely to be an airport in those mountains, right? With one of those ASOS anemometers. So you might be looking at finding a data source. Maybe there's a university maintaining an anemometer. Maybe there's data from the Forest Service. Can those data be interpreted and corrected? Are the records long enough? This is, I just say it's involved, but it's not impossible, right? You don't need to guess.
Yeah, that's a good point. The next question, when can we get to a point? Emily looks like she'd want to answer this. So when can we get to a point where the online tool gives a suggestion for the special wind speeds based off something similar to what was presented for Southern California, the Irvine contours? Emily, you want to jump in?
Gwen, I don't need to. I'm happy to. I would just keep it cleaned up. Okay.
Go for it. Yep.
I guess I'll turn on my camera. I think that's exactly. So first of all, the hazard tool for non-special wind regions has this. It already will give you the map for the different risk categories. And in fact, it will even give you, as Gwen said, maps for higher mean recurrence intervals and even less for serviceability. The state of California, SEAOC in particular, and this committee is highly driven to solve the problem inside California for special wind regions. Hence the different studies we have put together and this presentation here for you today. So we are slowly working our way through the state, ticking off the various special wind regions. The one we're presenting has particular focus on Southern California. We've just commissioned another study for a few other regions. And Gwen, I'm going to make my fundraising plea. If you would like to participate in helping us, it is not a insignificant cost, but we think that if we can get through these special wind regions, provide the guidance directly, get them incorporated into the hazard tools, it provides a lot of value, both for you guys as building officials, for us as practicing engineers. So we're working on kind of getting a bigger pot of money. And if that's interesting to participate in that, let us know. But yes, how close are we, Gwen? Few years, maybe.
Yeah.
Hopefully, depends on what region you're living in.
I mean, as David said, in the mountainous regions, we don't have data, right? We know the winds are larger, higher speed, but we don't know how much. And without actual data instruments, it's difficult. So there's a limit to what we can do based on airport records and anemometer records. The other thing, you know, I mentioned the mesoscale modeling. That's an actual fluid dynamics simulation, right? It's simulating storms, and that can be done in mountainous regions, but that's even more expensive. One other response about, you know, getting the hazard tool to do more. I'm going to share my screen for just a second here. So again, this is Kern County. If you go into Kern County and select ASE 722, these contours in the special wind region are there. So if you click on Mojave Airport, you will get a value between 110 and 120. So in this case, there is a special wind region, and the wind speeds within this special wind region have now been defined. So the special wind region isn't a big unknown to anyone. You can put any address in here that you want, and you will get an answer. And it tells you are in a special wind region, but it also tells you what the answer is. The other areas is really not telling you the answer. So the hazard tool does need to be improved here so that it doesn't give you an answer in a wind speed in a special wind region that hasn't been defined yet.
Now, Gwen, that's a good point to mention. You know, right now, the special wind region tool or the ASC hazard tool, when it does the mapping, it's just giving you the interpolation between the contour lines in the map, and it will give you, even if you are in a special wind region, a number. It does say, you know, you are in the special wind region, but it'll still tell you a miles per hour. So
Right, probably 95 or 96 if it's risk category 2.
Right.
You have to be
So
careful
I
not
believe
to be
that's one of the
misled.
questions that came in is I used the 722 hazard tool, and there were values that were provided for the special wind region.
Yeah.
So, you know, I think we do need to proceed with caution, or officials do need to proceed with caution with those numbers, because they could give you a false sense of what the wind speed should be if you're in that special wind region.
Right. Well, hopefully building official will go, you know I'm in a special wind region. So I either know the answer is, I might know the answer is not 95. So if someone comes in with an answer of 95, go back to the drawing board. Hopefully that building official has some defined value that's not 95 that tells what should be used in that special wind region. Okay, another question here. Are there resources the presenters can recommend for wind vibration analysis and requirement guidelines that are accessible to the practicing engineer in a small firm? So wind vibration analysis, that's really not not what we're discussing today. That's a whole nother mess. And you will find that ASC 722 is changing. In 728, it'll be dramatically different, and you may not be allowed to assume that your building behaves rigidly and doesn't get excited by the wind. So in ASC 728, we're all going to have to shift quite a bit in how we think of wind and how we think of structures. Are there specific resources? I don't know. Anyone on the panel want to try there?
I'll just say the pre-standard for performance-based design wind that became available during the last code cycle. It is free download. It has a lot of discussion about, I'd say, generally serviceability, flexibility, vibration. So I would start there. And then, as Gwen alluded to, if this is particularly interesting, there's a whole bunch happening in the code world right now that I'm sure that those of us on the code committees would be happy to pull some of that background research and make it available to you.
Take your Alka-Seltzer. Okay, next question. Is there a tool or map to determine if certain areas are within zone B? This is exposure categories B, C, or D. No. You have to use your judgment. There are formulas. You basically break, you know, the area around your structure into zones, and you look at each zone. Emily, you want to jump in?
I was just going to share, the commentary has some good examples and some aerial images to help you. And I will also just share at my firm, we've got a young kid who just threw some AI on top of this problem that grabs Google Earth and spits out an answer. So it is a pretty calculation intensive question. There's a way to truly run a number to say, is it B, C, or D? And again, I would push you to the commentary, but also say it's pretty programmable. It's pretty AI friendly. And I think there's probably paid programs out there that you could use. I would just always encourage you. This is going to be one of those ones that as an engineer, you want to nod your head at it and say, yes, this is right. I don't think you're going to want a program just to spit it out for you.
Steve, you're muted.
And as a shameless plug for SEAOC, there was several years ago, we did the SEAOC Wind Design Manual, which has an example of how to calculate your exposure and also goes in more depth of if you are intermediate between exposures, if you want to justify some value between B and C or C and D of how to do that. So there is a resource out there.
All right. So the last portion of our charrette is discussion. Okay, so I'm going to turn it over to Emily and Meaghan. And this is free form, right? I mean, you have some questions, but
yes. So I have some. Can you hear me?
Yeah, you're good.
Okay, great. Okay, so I have some questions just to foster some discussion with the people who are online. My first one is, and if you want to respond, I think you just go into the chat, and Emily,
just raise your hand. You should have a raise hand feature.
Oh, there we go. Raise your hand, and Emily will unmute you, and we can discuss. So my first question is, how do you develop the wind load criteria for your jurisdiction?
And I'm going to go ahead and throw in the chat the questions as you're doing them, just so people have access to them as well.
Is there a particular process you go through? Do you reach out to SEAOC or SEAOC? Do you read the new code?
We've got Jay. I'm going to ask you to unmute. Go ahead.
Yeah, so here we have been relying on the hazard tool. I think.
Where are you, Jay? Sorry, I just want to everyone.
Rialto. I'm assuming that's why they used Rialto. Okay. But anyways, you know, so we did rely on the hazard tool. We did have that confliction with the northern region, and so we may want to reevaluate, I guess, now. And then we also sent our recommendation to a consultant who has engineered staff, right? And so through that consultant, we kind of landed on the values that we have now. But now that I've had this opportunity with you guys, maybe we want to revisit. But yeah.
I didn't target you specifically.
No. I was glad you did. I think it's great because now I get the opportunity, once I get the video, to share with staff, and we can then discuss it. Because, you know, anytime someone comes in, and I don't know where the 130 mile per hour value came from, or, you know, for us at one point, my predecessor, but that is what is communicated often at the counter when applicants come in. So.
And Jay, one of the things I noticed from our survey that we did, or DSA did, and my analysis of it, and looking at other jurisdictions, you know, one of the things that I really like is if you have requirements, at least providing an option for an engineer to take the time and effort to go through and justify something that may be slightly less. If they can prove that it's exposure B versus C, or if they can, prove a lower wind, it's great to see that kind of commentary or comment to say, use C unless you can you can justify B, or it's nice to give the engineers an out, or the designers an out, if at all possible, if they want to take the time and effort to do that work.
So yeah, I definitely agree with you, Steve. Is anyone else on the line want to weigh in on how you develop your wind load criteria, or what you will accept from people submitting documents to your building department?
So far, no hands for you.
Oh, okay.
There is a question in the question and answer. I'll read it, and then it says the wind contour lines are a huge advantage. How do we get the contour lines shown on the special wind speed map through the hazard tool? This is a trick question.
I think
Yeah.
once you, oh yes,
Yeah.
I mean once you go into to one of the smaller things, don't they just go away?
Yeah, they go away.
Yeah,
So
it's like the special wind region. So it's a bit of a bug in the ASC hazard tool that we've found.
We've asked them to fix that.
Correct.
They take a while.
And we talk about special wind regions, but once we've developed the wind, I personally feel, and this is not the SEAOC thing, but this is my personal thing, is that it shouldn't be a special wind region anymore. Now we know what it is. It's just a regular wind region where we know the contours. So I think it's confusing if we have a special wind region and we already know the values, but that's just me.
I think you're not alone.
It just bugs me. It's like we know what it is now. We've done the studies, we've paid the money, and still they're still calling a special wind region, which is kind of confusing because they will give you values for ones where we don't know the data, but they also will give you values for where we do. So it makes it a little bit more confusing. All right, well, I will go to the next question if we have no other people who want to discuss how they've developed their wind load criteria. Do you feel that there's enough collaboration between your department and the structural engineering community? And a corollary to that is, what additional support, if you don't feel that, could you use from the structural engineering community? I'm hoping that this shred has been really valuable, but if there's something else that we could be doing as a SEAOC Wind Committee, we'd really like to make sure that we're being transparent about what we do and how that can assist you.
We have no lucky takers yet. We're throwing the questions into the chat for those who may have missed it. Jay, you are a winner. Go for it.
Right. No, I think, just before this, right, I know the 722 was coming up and it was going to be, so when you guys put this webinar on, I was like, oh, great, there's the chance now to capture or to learn from you guys, right? You guys are subject matter experts in this field. And so, and get the answers right. Obviously we also have some corrections to do as far as their wind speeds, but I think this is great. I think, and I know that it may be a change in topic, but the seismic design for earthquakes is also a change in the 722. There's all kinds of changes, right? So I think that, and I don't know if this is just for wind only and you guys don't deal anything with the seismic design. But
we definitely deal with seismic design, and Gwen and Emily and I'm not sure about everyone else, but are on those committees. So
right. So if you guys did something like that for similar, that'd be great. And then obviously making the videos available, I think that's great. And then obviously the chapters, the International Code Council chapters have all the building officials as members. If you guys sync with them once a year, and they're always willing to take people. I'm gonna bring it up to the Foothill chapter, which includes a lot of the Ontario, a lot of the special wind regions. So I will bring this up with them, and then hopefully we can collaborate, and you guys can provide us something for them.
Well, I think it's a good segue for my other question. I'm gonna skip and say, would a separate seminar in using the ASC 7 hazard tool be helpful?
If you're asking me, yeah, I think so.
Just leave Jay's mic on.
Yeah, I will. Jay's.
I
Anyone
haven't
else?
turned him off. Jay,
Oh,
you've remained
perfect.
off mute, so thanks for
Well,
being
thank
our
you.
friend.
Yeah, does anyone else on the call think that it would be helpful? I mean, if you don't want to speak, you could just put it in the chat or the Q&A.
Or you can do thumbs up. You can do
Or you can do thumbs up. Yeah,
thumbs
that's
down
also.
if no.
Yeah, we won't call on you if you don't want to, but if you think that a separate seminar on just how to use the ASC hazard tool, and as you know, we've discussed there are holes in it. If you think that a separate seminar would be helpful, then we would be amenable to putting that on as well.
And if there's feedback about the hazard tool, we can consolidate that and provide that to ASC, because a bunch of us are on the ASC 7 committee.
Yes, and it's always nice to have more people to weigh in on these things than you're the lone person on the committee saying we should make this change. But if you have a lot of people who have said, look, this is where we feel the hazard tool needs to be fixed, it gives us a little bit more ammunition.
And Jay, you mentioned the ICC chapters. Feel free. There'll be a follow-up email at the end with the white paper, the slides. We'd be happy to present this to ICC chapters when the recording's available. You can send it to, like, I assume it'll be a free thing because this was free. I can't promise, but I think it will be. You know, feel free to send it, let other building officials know. I sent out a lot of invites, but I got a lot of bounce backs because people move around. And
Yeah, no, absolutely. I will send it out to as many folks as I can, and you know, they will share it as well. So.
okay.
All right, my final question is, if you are currently in a special wind region, do you use the same design load throughout all the jurisdiction, or only in areas you determine are going to be affected?
And so this is Jay. This one goes back to
great
to what my question was, right, during the seminar was, look, yeah, I get one pocket of the city that gets special wind, right? And so you know, I'm not good with knowing how winds react and, you know, the complexities of wind, and I'm just gonna stay narrowly in this one, you know, on this side of the line, and I won't cross over, right? And so, you know, that's kind of, I guess, the thinking is like, hey, look, I'm so close to this region, why stop it here in the event that there's that one event that's going to be affecting a larger swath than just what's drawn, right, or what's in the hazard tool. So I guess that's kind of the thinking. So I don't know if you guys can answer that, or.
Well, I guess, yeah. So my question to you would be, you know, can you get an engineer to convince you that, no, we don't need to be in the special wind region? Or is it easier just to say, look, I mean, we don't, you know, it's literally, we're crossing a strait from from one to the other. And now you're all of a sudden in a special wind region. So we would be more comfortable, perhaps. I guess that's my question to you.
Yeah, no, we're definitely gonna just be on the more cautious side, right? Always, I think that's, you know, and but I have no issues, you know, going with the hazard tool. Hey, the hazard tool says this, I'm okay. I'm kind of like black and white that way, but you know, for sure, a lot of other building officials may not be, right? So,
anyone else want to weigh in? Again, you don't have to. I won't require you to speak. You could just put it in the chat or the Q&A.
Got one more hand up. Hang on one second. Patrick.
Oh,
hopefully you can unmute here. There you go. You're up.
Yes, can you guys hear me?
Patrick, you should be able to speak.
Oh, we can't hear you, Patrick. Are you speaking?
Oh,
you are unmuted.
Hello?
There we go.
yes.
Yes, there we
Gotcha.
go.
Can you hear me now?
Yes.
Sorry about that. First of all, I just want to say thank you, Jay, for speaking up. Definitely appreciate that. I'm very close to Jay as far as I'm here in San Bernardino. So I'm right next door. I think to help Jay out, A lot of that special wind region is north of the 210 freeway. So the 210 freeway could be a boundary line that anything north of that could be a wind speed of 115 mile per hour versus the 95 mile per hour. Why am I coming up with that? I'm just using 115 because that's what we use for Irvine, that example there.
Mm-hmm.
And it went from 95 to 115. But the 210 kind of sets a boundary. And really, knowing Rialto and the city of San Bernardino was the same way, where we had a special wind speed that was just north of the 210 freeway for the city of San Bernardino as well. But it seems like that area right there is just kind of a wind tunnel that just comes down the 210 freeway. And that's what I'd say, probably north of the 210 freeway. I know that that's, if you look at that map, he zoomed in on it, you'll see that it's kind of curves and whatnot, and goes above north of the 210 freeway through Rialto's, where that special wind region is.
So you would be more comfortable just keeping it as the freeway would be your boundary.
Yeah.
Yeah.
That's a great point. Yep, that's a good point.
Or else, if they did come up with special, use the tool. But if it was a special wind region, use the 115 mile per hour, because right now the basic is 95. Jump from 95 to, I think what you said, 130. That's huge. And I do know where that 130 comes from. That 130 actually comes from, if you go back in the codes and look at it, at one time it was ASD, it was LRFD, went back to ASD. It kind of bounced back and forth. That 130 was based off of the LRFD design, which at that time Rialto was, I think, 120, 122 or something like that. If they did the math right, I don't remember. There was a conversion in one of the building codes that you can convert from the LRFD to ASD, and that's how that 130 actually came about.
Oh, that might have gone the wrong direction.
Well, the problem is it stayed at the LRFD value,
Yeah.
and then we went back to the ASD value, which is a lower value, and it just stayed at this 130, not knowing that there's other variables in the wind speed that actually changed.
Well, we've actually not gone back to ASD. Like ASC 722 and ASC 716 are LRFD strength design. So
Absolutely. But there, I think it was like the 2013, 2015 codes. There was some value there where it really changed huge, and obviously you would know. Where
it dropped from like 110 to 95, right? That was from 2010 to 2015 ASC's versions. And that we weren't reverting back to ASD. It was actually, they had better data. There was a giant wind study done at the ASCE 7 level, and they realized the contours were too high in the Western US. So
and that 130 comes from that time of when they were higher at that time.
Okay.
And it just kind of stayed there.
Please. Yeah, I mean, that difference, right? The difference between 130 and 95. That's
huge.
37% change in wind speed, but then you square it, so it's an 87% change in pressure.
I mean,
that may not govern like bigger buildings, but it will certainly govern the cladding, and it probably governs house design.
It'll definitely govern house design, most likely in an area where you got the San Andreas fault line not too close, not pretty close by.
Yeah.
Somehow wind speed's controlling your lateral design there. Because it is 130, so it is pretty high.
Yeah, so I mean, certainly, and this is just I'll turn my camera. My perspective would be, let the engineer do the engineering. If you need to set like an easy to find boundary, like the 210, you can do that. The hazard tool now is sufficiently sophisticated that you can just put in the address and it'll tell you if you're in the special wind region. It won't give you a value. So what building officials really need to do is say, okay, if you're in the special wind region, here's what you use. It's unfortunate, but there's still going to be this big jump, right? It'll jump from 95 to whatever value you have as you cross the street into that special wind region. long term, like we've talked about, if we can get contours, it won't be this falling off a cliff or falling up a cliff thing. It'll be a more gradual thing, and then you won't have that mess of, well, it's just across the block and now it's huge.
Yeah, and I do want to point out that 130, like Jay was saying, came from previous building cycles, and we didn't have the hazard tool back then.
No.
And it was up to the city, knowing that there was a portion of their city in a special wind region. What do we design it for?
Yeah,
I don't know.
And that's tough. I mean, I'm not a meteorologist. I assume very few building officials are meteorologists or wind engineers, and you're being told pick a wind speed.
And really that 130 was derived from a value, I believe at that time was 95 miles per hour based off the fastest 1 mile, which at that time the common wind speed was 70 miles per hour. So, and then the building code at that time had some sort of equation that was in there that you could change from the LRFD or the ASD to the LRFD, and that's where the 130 came from.
Got it.
It was the 95 that got inherited from just previous building officials before that.
Meaghan,
Okay.
can you see there's another?
Yes,
Okay.
yes, so somebody did answer in the Q&A. Thank you so much. So this is AJ from La Quinta. And he says La Quinta uses a predecessor building official value of 110 with exposure C. But since 2017 has a disclaimer on the website that engineers are responsible for considering all site-specific conditions. So we do accept ASC tool results. Great. And then he says, collaboration is usually just calls from engineers expressing concerns about plan check comments. I'm sorry, that's not the relationship that we would like. We use a structural plan review consultant, but if there are other building official topics, I would participate in another discussion. Great. And the ATC hazards by location had us in partial coverage. So yes, we were allowing various speeds, but most people go with the website published value of 110 without hesitation and do not use the design tool data, even though it is included in their calculations. Okay, well, that's good to know. So maybe they're, the engineers are just concerned that they're going to have a plan check comment if they don't use the 110. So they would prefer to maybe go that route rather than have to provide a plan check comment and redesign their building. That's from my perspective as an engineer. That's where I'm coming from. But that's really good data. So thank you so much for that.
I think I'd like to add to that. If,
there you go.
If an engineer sees, use exposure C 110 miles per hour, they're very unlikely, unless they have a really good working relationship with that jurisdiction and they know how the jurisdiction operates. You're probably going to go, well, yeah, the hazard tool says 95 in this specific area, and I think it's exposure B, but I don't want to take the risk of going all the way through design either the cladding or the building or whatever, and then submit it and then get, embarrassed and have to eat all that design time as I redesign it for whatever, 110 miles per hour and exposure C, right? So you'll be like, well, it says that. If you're in the position where you can write the code in your jurisdiction, and you do want to have a default, it should also say something along the lines of, however, properly substantiated, but wind speeds and exposures will be accepted. That's I would say it's okay.
If you add that sentence to your what you have posted online, then you would.
It's still risky though. Like as an engineer,
it is
designing, right?
Yeah.
You're like, well,
Correct.
I think it's substantiated.
Yes.
Someone else could think it's substantiated. Do you run the risk of, and if it's a big project and there's a ton of money that can be saved by using exposure B, like let's say it's a skyscraper, and it's the cladding, right? So you might save a lot of money. So it'd be worth it. You probably want to have a design meeting with the building official first.
Yes.
But you wouldn't want to just do exposure B and then find out, well, someone else thinks it's more like exposure C.
Yeah,
'Cause
we
there
just
is
had a
some-
discussion in our committee a couple days ago that said, and someone said it's really hard to justify exposure B if someone thinks it's C. And yes, it is. I mean, there is like Emily said, there is a calculation on how you can do that, but yes, sometimes it's hard to make that argument.
Anything else? And Meaghan, you're muted. I don't know
Sorry.
what happened.
Knew that was going to happen. So AJ came back and said that he's going to update the website to clarify what they mean
Oh,
when
cool.
they say it's excellent. Awesome.
Thank you.
All right. So my last question, maybe not a question, more of a plug. Would your jurisdiction potentially be willing to contribute funding for a wind study that would better define the wind speeds in the special wind regions in California? This is our catch for our free charrette. As Emily and Gwen said, you know, these studies are quite expensive. We definitely have our hat in hand to get them done. We would love it if ASC would give us some money, but they will not. So if you guys have any spare quarters in your budget, we would really appreciate, even if it's, you know, $500. It goes a long way to getting these studies done so that we can make sure that that especially Southern California, the special wind regions are well understood and we can give you actual data.
No one volunteer all at once, though. Just
It's just food for thought. You don't have to. No commitments required today. But yeah, if you do find that you would be open to helping us fund that, we would really appreciate it.
or if ICC maybe, you know, jurisdictions might have difficulty, particularly in this economic environment, but maybe ICC might consider it, or ICC chapters, building Calbo type chapters. I don't know. Does Calbo still exist?
Yes, Cabo does still exist.
Okay, all right.
And Patrick Johnson, he's a big wig at the Foothill chapter, so you know,
Oh,
he's a really smart guy. He works on a lot of jurisdictions too. So
yeah.
Appreciate that, Jay, but not really.
Okay. Like I said, we unfortunately don't have the money that we'd like to fund these studies, so we're always asking if people can help us out.
All right, we're a little bit ahead of time, but we knew this discussion would be, you know, we have to see how it goes. So I think we are good. Unless anyone else has anything else they'd like to discuss. I'm gonna put a slide up here on the screen with contact information. Right now. All right. Thank you. Like, I hope you all got something out of this. If you have any questions, please, you can take a screenshot of this, but you will get copies of the slides. Please feel free to reach out to us. We're happy to answer additional questions and collaborate further. And that's it. Thank you. Happy holidays too.
thank you guys.
Thank you.